Hi everyone. Today we are going to start module number 2. See, the module 2 deals with network theorems. See, in module 1 we discussed about some fundamental basic concepts of network. Module 2 deals with network theorem. In module 1 we discussed about some fundamental laws like Ohm's law, Kirchhoff voltage law, Kirchhoff current law, and we applied these laws to find out electrical parameters like loop current, node voltage, branch voltages and all. See, network theorems are the proved properties to find out the solution for any given network or any given complex network. In this chapter, we are going to discuss 6 theorems. There are 6 theorems in this module. So, number 1, Reciprocity Theorem. Second one is Millman's Theorem. Third one is Superposition Theorem. Fourth one is Maximum Power Transfer Theorems. Then Miller's Theorem. So, there are 6 different theorems we are discussing in this chapter. Now, let us move on to the first theorem, Reciprocity Theorem. See, in all the theorems, the theorem statement starts with in any linear bilateral network. Because in order to apply any theorem, the first and very important condition is the network should be linear and bilateral. What is linear elements? See, output can be represented as a response and input is excitation. When output is directly proportional to input, such elements are known as linear elements. When output follows the input, output varies linearly with respect to variation of the input, such elements are known as linear elements. The elements which follows the linearity property, such elements are known as linear elements. Bilateral means, say, there is no polarity for resistor. You can connect in this way or you can connect in ulta also. There is no fixed polarity like plus and minus. It transfers equal amount of energy. It transfers equal amount of energy in both the direction. Okay, it transfers equal amount of energy on both the direction. Such elements are known as bilateral elements. For example, if you consider diode, there is a fixed polarity, anode and cathode. According to polarity only you should connect. Okay, anode to cathode forward bias, cathode to anode reverse bias. Okay, so but there is no such kind of polarity for resistors, inductor and capacities. Even if the polarity of supply changes or reverses, the VI relation remains same. Such elements are known as bilateral elements. So, in order to apply all these theorems, whatever the 6-7 theorems are there is a condition like the circuit should be linear and bilateral. Okay, that's why all the theorem starts with the sentence in any linear bilateral network. Is it clear? Now, let me state the reciprocity theorem statement. Anyhow, the statement starts with in any linear bilateral network, a source of voltage V in one branch produces a current I Ix is the current, produces a current in another branch. So because of this voltage, it produces Ix in this branch. When the same voltage source acting in the second branch would produces same current in the first branch, then the circuit is said to be reciprocal. Let me repeat. When a source of voltage V acting in the first branch produces a current Ix in the next branch. After that, when the same voltage source acting in the second branch would produces the same current, means what? Same amount of current as Ix in the first branch, then the circuit is said to be reciprocal. Okay, very simply we can say source and response. Supply is nothing but source, response is nothing but current Ix. Source and response are mutually interchangeable. Such networks are known as reciprocal networks. Is that clear? Now, in all the theorems, first we are going to prove the theorem by considering any general circuit or a simple circuit. After that, yes, we are going to solve the problems based on the theorem. Now, first I would like to prove this theorem, reciprocity theorem. So, now just find out what is Ix. See, before that, just see the circuit. There is a voltage source in the circuit with a resistance R1. Next, R2 and R3 are connected in parallel. What is Ix? Ix is the current through R3 and I is nothing but total current in the circuit. That is the total amount of current driven by this supply. Is that clear? Now, in order to find out Ix, say, you know current divider rule. What is current divider rule? When two resistances are connected in parallel way, by knowing the total current, we can find out the branch current. How? If you want to find out current in this branch, so opposite side, another resistance value R2 divided by R2 plus R3 into total current I. What is the total current in this circuit? I. That's why Ix, in order to find out Ix is equal to, what is the other resistance? R2 divided by sum of these two resistances, R2 plus R3 into total current I. Is it clear? That is Ix. But in order to find out Ix, first we need to calculate what is I, because right now we don't know what is the value or what is the equation or what is the expression for I. So, in order to find out I, see, what is I? I is nothing but total current. By Ohm's law, what is I? I is equal to V by R. Then what is total current I? I is equal to V by total resistance RT. I is equal to V divided by total resistance RT. Is that clear? Now again, in order to find out I, first we need to calculate what is RT. RT means total resistance, or else we can also known as effective resistance of the circuit. Say, voltage is usually measured under open circuit condition. That's why we can open the terminal at this point. If you open the terminal at this point, how the circuit looks, say, we can open the terminal at these 2 points. Say, now the circuit looks like this, R1, next R2 and R3 are connected in, R2, R3 are connected in parallel. Now easily you can find out what is the effective resistance or total resistance between these two terminals. How we can find out? R2 into R3 divided by R2 plus R3, that entire combination in series with R1. How we can write this? RT is equal to R1 plus R2 into R3 divided by R2 plus R3. Okay, just simplify this equation. R1 into R2 plus R1 into R3 plus R2 into R3 whole divided by R2 plus R3. Okay, see, first we wrote the equation to find out Ix. But in order to find out Ix, first we need to calculate I. Then written the equation for I. So what is I is equal to V by RT. So you need to find out what is RT. Now we have a expression for RT. Now substitute this RT in the above equation. Substitute RT in above equation. Therefore I is equal to V into, because RT means R1 R2 plus R1 R3 plus R2 R3 divided by R2 plus R3. The denominator goes to numerator, V into R2 plus R3. R2 plus R3. Then remaining, what is that? R1 R2 plus R1 R3 plus R2 R3. So we got the expression for I. So by knowing I, yes, we can find out Ix. So what is Ix? Ix is equal to R2 divided by R2 plus R3. R2 plus R3 into I. What is I here? I is V into R2 plus R3 whole divided by R1 R2. Next R1 plus R3, R1 into R3 plus R2 into R3. R2 plus R3 and R2 plus R3 will get cancelled. Okay. So therefore Ix is equal to R2 into V divided by R1 R2 plus R1 R3 plus R2 R3, and call it as equation number 1. So we derived the expression for Ix in the first case. This is case number 1, because voltage source acting in the first branch and produces a current Ix in the second branch. Now in case 2, what we are going to do? Just we are interchanging source and response. Just I am shifting this voltage source into this branch and I am finding the current in the previous position of the voltage source. If the current is same, then the circuit is said to be reciprocal. Is it clear? Now let me write the case 2, or directly I will write the circuit diagram. R1, because just remove the voltage source. Next another resistance R2. Next one more resistance. Just I am removing this voltage source and placing in this branch. Is that clear? So what is that voltage source value? Minus to plus V. Is that clear? So now let me call the current in this branch is Iy, because in first case I used the variable Ix. Let me use another variable Iy, and now the current in this path is I dash. So in first case the total current is represented as I. In second case let it be I dash. Okay. Now what is the formula to find out the Iy? Once again you can use current divider rule, because R1 and R2 are connected in parallel. Is it clear? Therefore Iy is equal to, so if you want to find out current in this branch, other resistance value R2 divided by R1 plus R2 into total current I dash. Total current I dash. Now, so in order to get the expression for Iy, first you need to find out I dash. I dash. I dash is nothing but total current in this circuit. So, what is the total current in this circuit? V divided by V is total voltage, because one and only voltage source we can see in this circuit, total voltage divided by total resistance RT. Now, what is RT for this circuit? Because voltage is measured under open circuit condition. Now, the circuit looks like this. See, the other end, next R1 and R2 are connected. R1, R2 are connected in parallel. This combination next connected in series with R3. Okay, therefore, what is RT? RT is equal to R1 into R2 divided by R1 plus R2 entire combination in series with R3. Is it clear? Just simplify this RT equation. RT is equal to R1 R3 plus R2 R3 plus R1 R2, the whole divided by R1 plus R2. So, after finding RT, just substitute in I dash. So, therefore, you will get the equation for I dash. So, I dash, just substitute in this equation. Therefore, I dash is equal to V into R1 plus R2 divided by R1 R3 plus R2 R3 plus R1 R2. Okay. Next, after finding I dash, just find out Iy by substituting what is I dash. Therefore, Iy is equal to R2 divided by R1 plus R2 into what is I dash? So, V into R1 plus R2 whole divided by R1 R3 plus R2 R3 plus R1 R2. Okay. So, R1 plus R2 and R1 plus R2 will get cancelled. Therefore, Iy is equal to R2 into V divided by R1 R3 plus R2 R3 plus R1 R2, and call it as equation 2. Okay. From equation 1 and 2, just see the equation 1, R2V divided by R1 R2, R1 R3, R2 R3, R1 R2, R1 R3, R2 R3. Therefore, equation 1 is exactly same as equation 2. Hence, it proves reciprocity theorem. Again, let me repeat the statement of reciprocity theorem. In any linear bilateral network, a source of voltage V in first branch produces a current I in the second branch, and the same source acting in the second branch would produce the same current in the first branch. Then the circuit is said to be reciprocal circuit. Thank you. Let us solve one problem based on reciprocity theorem. See the question, find I. Where is I? The current through 2 ohm resistor is I. Find I in 2 ohm resistor and hence verify the reciprocity theorem. So, while solving any reciprocity related problem, we need to solve the same problem 2 times. I mean, first there is a voltage source here and produces a current in 2 ohm resistor. Okay, then the same voltage source acting in this branch, and what would be the current in the first branch. So, that is the procedure to verify the given circuit is reciprocal or not. So this voltage source value is 20 volts. Okay. Say, while discussing the module 1, so many times I mentioned module 1 is the fundamental for the upcoming modules, because here this is the only one step to verify the reciprocity theorem. Other than that, what are the methods and procedure we are using, that is completely depends on loop analysis and nodal analysis. Is it clear? See, you can apply any method in order to find out I. See, there are 3 loops, 1, 2, 3, but there are 2 nodes. You just think and decide which method consumes less time. Is that clear? If you apply KVL, you will get 3 equations with 3 variables. If you apply KCL, you will get 2 equations with 2 variables. But doesn't matter in case of DC circuit, but it matters a lot in case of AC circuit. That's why try to choose a right method, which method saves the time and avoids the mistakes. Is that clear? I would like to solve this problem by using nodal analysis method. So, let me mark how many nodes in the circuit. There are 2 nodes in the circuit. Let me call it as V1 and V2. All of you already know how to apply KCL for any circuit, I mean any node. See, when you are applying KCL for this V1, just consider this is higher potential node, therefore all the branch currents are leaving from the node. V1 to ground, another terminal is connected to ground. At the same time, one more voltage source is there. According to this voltage source polarity, it drives the current upwards. That's why V1 minus 20, after that where it is connected, ground point, minus 0, and so first to KCL for node 1, KCL for node 1, apply KCL for node 1. V1 minus 20 minus 0, this is the potential difference in this branch, no need to write this 0. V1 minus 20 divided by resistance value 4, because I is equal to, we are finding the branch currents, right? What is I? I is equal to V by R. What is V? V is nothing but potential difference divided by R. What is the potential difference? If you consider this is a higher potential current flowing from V1 to this point, right? That's why V1 minus this voltage. Is that clear? So V1 minus 20 divided by resistance 4. Potential difference divided by resistance is nothing but current in the first branch. Similarly, what is the current in this branch? We know the potential difference because this 4 ohm resistor is connected between V1 and ground. So, potential difference is V1 minus 0 divided by resistance 4. So, plus V1 by 4. Okay. Now, the third branch 4 ohm resistor is connected between V1 and V2. The potential difference, it may be V1 minus V2 or V2 minus V1. We don't know right now, we don't know what is the value of V1 and V2. After finding on V1 and V2, then only we can come to the conclusion whether the current is flowing from V1 to V2 or V2 to V1. But right now we are applying KCL for node 1. Just assume node 1 is higher potential. I mean current is flowing from V1 to V2. Therefore, what is the potential difference? V1 minus V2 divided by what is the resistance? 4. So, V1 minus V2 divided by 4. Any other branch connected to this node? No. Only 3 branches are connected to this node. So, there are 3 factors, 3 terms that is equal to 0. Okay. Just simplify this equation. Yes, how we can simplify this equation? V1 by 4 minus 20 by 4, 5 plus V1 by 4 plus V1 by 4 minus V2 by 4, that is equal to 0. Just take a V1 as a common factor, 1 by 4 plus 1 by 4 plus 1 by 4. Okay. So, next minus V2 by 4, that is equal to minus 5. Just shift to right side, plus 5. So, after simplifying this factor by using your calculator, you will get 0.75 V1. What is 1 by 4? Minus 0.25 V2, that is equal to 5, and call it as equation number 1. Is it clear? So, this is the KCL equation for node 1. Just simplify and write the equation. That is equation number 1. Next, KCL for node 2. KCL for node 2. Yes, just see the circuit. Node 2 consists again 3 branches. Now what is the current in this branch? Now you are applying KCL for node 2. Just consider current is flowing from V2 to V1. Therefore, what is the potential difference across 4 ohm resistor? V2 minus V1 divided by resistance 4. V2 minus V1 divided by 4. What is the current in this branch? Because the potential difference across 8 ohm resistor is V2 minus 0 divided by resistance 8. So, V2 divided by 8. Okay. What is the current in this branch? Again, this 2 ohm resistor is connected between V2 and ground. What is the potential difference? V2 minus 0. So, what is the current? V2 minus 0 divided by 2. V2 minus 0 divided by 2, that is equal to 0. Okay, again simplify this circuit, you will get minus 0.25 V1 minus 0.25 V1 plus 0.875 V2, that is equal to 0. Just similar, just like a previous step. Just group the V1 terms and V2 and simplify by using your calculator and call it as equation number 2. Right now there are 2 equations, equation 1 and equation 2, and 2 variables. What are the variables? V1 and V2. So easily you can solve these 2 simultaneous equation by using your calculator. So you will get V1 is equal to 7.36 volts and V2 is equal to 2.10 volts. But the question is, find I in 2 ohm resistor, correct? So how we can find out 2 ohm resistor? See, if you want to find out current in 2 ohm resistor, what is the formula? I is equal to V by R. What is V? V is nothing but what is the voltage across 2 ohm resistor? Voltage across 2 ohm resistor is same as potential difference across 2 ohm resistor. Correct? So what is the potential difference across 2 ohm resistor? V2 minus 0. Then what is I? Potential difference divided by resistance. Anyhow, we know what is V2. So V2 divided by 2 is nothing but I. Is it clear? Therefore, I is equal to V2 divided by 2. So what is V2? 2.10 divided by 2. Is it clear? Say, this term already we are written here. Say the third term is nothing but the current in this branch. Okay. So how to find out current in this branch? V2 divided by 2, that gives 1.05 amps. Case 1, what is the current? 1.05 amps. So similarly, now what we have to do? Just replace source and response. See, I am just removing this voltage source, okay, and placing the voltage source at this point. Minus 2 plus 20 volts. Now find out what is the current in this branch. Let me call it as I dash. Is it clear? So reciprocal theorem statement itself, it is a source and response are mutually interchangeable. Now find out current in the first branch. If the current is same, then the circuit is said to be reciprocal. Okay. Now this is the circuit for case 2. This is the circuit for case 2. Apply KCL for node 1. Apply KCL for node 1. Yes, V1 by 4. See, in this equation V1 minus 20 by 4. But now we removed that voltage source. Instead of saying removed voltage source, Just replace voltage source by a short circuit. Replace voltage source by a short circuit, and the same voltage source is placed in the next branch. I mean where we calculated the current in the same branch. V1 by 4 plus V1 by 4 plus V1 by 4, V1 by 4, next V1 minus V2 divided by 4. V1 minus V2 divided by 4, that is equal to 0. Is that clear? Just simplify this equation, you will get minus 0.75 V1 minus 0.25 V2, that is equal to 0. And call it as equation 1. This is for equation 1 for case number 2. Is that clear? Don't get confused, otherwise we can name it as equation 3 also. Now KCL for node 2. KCL for node 2. Just consider the node 2. Yes, V2 minus V1 by 4. V2 minus V1 by 4. Next V2 minus 0 by 8. V2 by 8 plus, now there is a voltage source here, correct? V2 minus 20 divided by 2. V2 minus 20 divided by 2, that is equal to 0. Is it clear? Just split all the factors and take a LCM, or else you can use your calculator and simplify. You will get minus 0.25 V1 plus 0.875 V2, that is equal to 10. Okay, and call it as equation number 2. Say in case 2 the circuit is different. Again apply KCL for both the node in case 2 and simplify the equation. You will get two equations with two variables V1 and V2. Use your calculator and solve these two simultaneous equations. You will get V1, value for V1 and V2. V1 is equal to 4.21 volts and V2 is equal to 12.63 volts. Now in order to prove the given circuit is reciprocal, where we have to find out the current. So the position, the previous position of the voltage source, and call it as I dash. I dash is equal to, how to find out current in this branch? So what is the current in this branch? I mean 4 ohm resistor, the potential difference across 4 ohm resistor divided by resistance. What is the potential difference across 4 ohm resistor? That is nothing but V1 minus 0. Therefore V1 by 4. What is V1? 4.21 volts divided by 4. Just use your calculator and simplify. You will get again 1.05 amps. In first case, what is the current? 1.05 amps. After interchanging source and response, what is the current? 1.05 amps. So I is equal to I dash. Then the circuit is said to be reciprocal circuit. Thank you.